and the advisory editorial board of Transport Reviews, Journal of Transport and Land Use, Transportation Letters in English, and Economic Geography, World Regional Studies, and Tropical Geography in Chinese. Her presentation topic today is competition between high-speed trains and air travel in China, from a spatial to spatial temporal perspective. Without further ado, may I pass the time to Professor Wang? Professor Wang, please.
Okay. Thanks for the introduction. Could you see the full screen?
Yes, I can see your screen now.
Okay. Okay. Hello, everyone. It's my great pleasure to be here. My research team has did quite a few research about high-speed rail, and I think most of them could be included by three areas. The first is about the new location shaped by high-speed rail, and the second is about the interaction between high-speed rail and regional development, including economic growth, innovation transfer, urban mobility, and urban systems reshape. And the third area is about the competition between high-speed rail and air travel. So today the presentation was done by me and with my colleague Dr. Huang Jie and my master student Jing Yue, who is now the PhD student and she is now studying in the University of Florida. So today the presentation title is about the competition between high-speed rail, high-speed trains and air travel in China from a spatial to spatial temporal perspective. And the research is quite is kind of like for the geographical background because my education background. And here, first we see the rapid development of high-speed rail in China. And I think all of you already know that actually in 2021, China already has a total mileage of over 40 kilometers. And with the high-speed rail network plan, we could see the finger or the picture in the oh, okay, I see. Okay, the picture here. Here is the planning for 2033, and with 8 vertical lines from north to south and 8 horizontal lines from east to west. By 2035, China will build a high-speed rail network with the mileage of 70,000 kilometers. And all cities with population over 500,000 will be connected to the network. So today, the high-speed rail has played a more and more important role in the intercity transport market. For the finger in the up, we could see that in 2018, the high-speed rail has took over 2 billion passengers, and the number is 2.2 billion passengers. The number is kind of like 3.5 times the volume of air passengers because in 2019, the total air passengers is 0.66 billion. And for the market share, in 2018, the high-speed rail has the proportion of over 60% of rail passengers and 12% of all transportation modes. And for the background, I would also introduce the spatial expansion of high-speed rail network in China. We could see from the fingers left. It shows the whole network, evolution from 2008 to 2016. We could see that firstly, it is not as a whole network. The Chinese government just built some short distance or media distance between cities in the economical developed areas. And we could also see here, we got the whole map for 2080, and we could see that it shows like a quite integrated network for the whole country, from the west to east, and for the south or the mid center to northeast China and the north China, and also kind of like to the some provinces in the east part of China. And then we could see that the traffic volume by hospital and the air travel in China. We did the dynamic flow networks by hospitals in 2018, and the right figure is about the air travel flow. It only shows the flow is over 300,000 passengers between cities. For the two fingers, we could see that most flows are located in the southeast part of the Huhuan Line. Maybe I think most the audience already know the Huhuan Line in China, because most economic activities and kind of like over 90-60% population are located in the southeast of the Nile. So we could also see that all the traffic volume between cities, between intercities are also located in this part. So here we go back to the research problem or the research issue. Well, here we could also see that the factors for the data analysis between the competition between hospital and air. We could see that the entry of high-speed rail challenges the development of air transportation, and an increased number of people would like to take high-speed rail as an alternative mode for intercity travelers. For the left finger, we could see that the shares of transportation modes in China I didn't put the market share of roads because that's quite large. It's about over 70%. So I didn't show that. For the finger, we could see that here is the market of the conventional and okay, I just the conventional railroads, and with the red line, we could see that the pastors we are the proportion of pastors taken by hospital grow very rapidly, and the green line is about the air. For the right finger, we could see more details about the competition between air transportation and high-speed rail. In this finger, I show the annual growth rate of air passengers in city pairs with high-speed rail competition is the dotted lines, and the solid line shows the annual growth rate of air passengers in city pairs. Without high-speed rail competition, we could see that the growth rate is quite differently for these city pairs. And the finger in the middle, it shows that more and more passengers could have an alternative transportation mode between the city pairs. So we could see that the growth rate of air passenger volume became slower, and in 2012, we could see that in this year, the passenger volume by hospital rail exceeded air travel, and now it's kind of like three and a half times of the volume by air passengers. So Secondly, I introduced the literature review about the research. There are a lot of studies have already started the competition between hospital and the air travel. Most of them are from the supply and demand perspectives and some research, but I think most scholars they concern more about like the distribution of the hospital and the airports, and some research concerns about like the reasonable distance for hospital or and for air travel, and some others concern about the service area of the hybrid train stations and airports. Some scholars also study the exposed effects of high-speed trains on air service. Most of these studies are done with the case studies. I think which could be included into mode substitution and induced demand. Furtherly, some economists they would like to apply the econometric models in quantify the exposed impacts of high-speed trains on airline industry. Also, there are some other studies, but I will not introduce the details. What I care about here is from the survey we did a few years ago, we found that the time slot, or we say that the depart time or the arrival time is quite important for people to choose the transportation mode or kind of like which flight I would like to take. We also found it's quite important to improve the efficiency of hub airports through building flight waves. So we could say that departure time and arrival time is quite important. We also know that the air tickets, the price of air tickets differs greatly. With 1 day, we know that it's quite cheap for the red eye flights, but for the flights in the peak hour, we almost have to buy the ticket with the full price. So we found that the departure time or the arrival time is quite important for people to choose the transportation modes. Here I introduce about the reasonable distance for hospital and air transportation. We know that China has a huge land area, so we have the longest hospitals, and so we could do a statistic analysis about the distance decay of the two transport modes. We found that the data is in the year of 2017. We found that if the distance is less and equal to 7 kilometers, the uh, in this segment, it is dominated by high-speed rail, but if the distance is over 1,100 kilometers, the market share is almost dominated by air. And the distance between this part, we could see that is quite competitive. It's kind of like half market share. So when we did the statistical analysis, we put forward our research question is how do people make a choice for taking a high-speed train or a flight for an intercity travel? The current literature generally categorizes them into three groups, or we say three factors will influence, which are individual social economic factors like the gender, the age, the income, and the education of the travelers. And the second is about the trip attribution, including distance, location of terminals, origin city, destination city, and the third is about transportation modes. We say that is a price, travel time, frequency, safety. safety. But we also think that we already say that it's commonly known that the departure time play quite important roles in the decision-making process. They are less discussed in current works. So in light of this fact, we aim to discover the interaction between the city pairs with air and the high-speed rail for the temporal dimension. Okay, so here is the analytical framework. Our question is about how to define the competitive network of two travel modes, because we just talked about it is for a decision making. So for the travelers, he should have the direct flight and direct high-speed trail for a choice. So if we only focus on the competition between these two modes from the perspective of time slots, how to do it? So the first procedure for us is construct the overlapping network. For the overlap network is constructed by city pairs served by direct high-speed trains and flights, which means that the passengers between these city pairs could have two alternative transport mode choices: direct high-speed trains and direct flights. That's the basis for the competition. I think for the network, we already consider about like the reasonable distance for the two transportation modes. If the seat pairs only have one transportation mode, then we think there is kind of like no competition network there. So we built the overlapping network, which is we define it as the potential competition network. So the second part is how to define the time slot. We said before, we think if the departure time is similar and the potential competition is high. So the second part for the master is how to construct the time window message for it. And we could see about the assumption here for we analyze the time window approach. The basic assumption we think that is if a high-speed train and the direct flight between the same cities, they have more closer departure time, and we seek more similar service attribute was supplied, and the greater possibility it is for potential competition. Also for the arrival time, we also have the same kind of the similar kind of assumption for the analysis. So here is the question about here is how to quantify the similarity of time slots between high-speed trains and flights. So we employed the time window approach, which means that we set the departure time for each flight, or we could also do that for the arrival time for each flight here. We just take the departure time as the research cases. So for each flight, the program we could search the high-speed trains based on its departure time and collected the high-speed trains whose departure time is within a time window. The time window could be set as like as many as like for just 5 minutes or 10 minutes. It could also be set as like the maximum time window for 8 hours or 2 hours. So the second, we have a definition is about the TDI. We call it time difference index. It means like for each city pair, TDI represents the average temporal difference between flights and their closest train competitors with one day schedule. And then we got the TDME. It means like for a flight, TDME indicates the minimal departure time difference between the flight and its train competitor. So for this analysis, we did it all for the departure time for the departure time. And then we could do the data processing. We just used 1 day because we used the time window approach. 1 day for the domestic air transportation of China and also the domestic hospital trains in China. So because it just for 1 day, we know that the hospital train frequency is quite stable, like for Monday to Sunday. But for the flight, is quite dynamic or changeable. So we use the data of Saturday because it has the maximum number with 1 week. For the definition of a high-speed train, we are not to introduce it because Baker already did that. So what I need to say, we defined the cities as the basic units for the research, which means that if a city has 2 or more high-speed train stations or 2 or more airports, we will combine the data to one city. So finally, we got the data for over 360 cities in mainland China. So here we could see that for the data set I just introduced, it is in 2017. So here we could see the overlap network. Actually, the overlap network in China from 2003 to 2017, it increases quite rapidly. In 2017, we could see that we got 83 cities and 460 city pairs are directed, which means it is 920 city pairs in two ways. And we could see the evolution of the overlap network from 2007 and then 2011 and 2015, 2017. We could see that the overlap network is expanded from east to west, and now the competition network is located in the southeast of the Huhuai Yunnan I just introduced. So here we got the overlap network. We could see some statistic numbers. Like for in the overlapping network, we could see the average number of trains and the average number of flights. They are quite comparable. And we could also see, but the maximum number that's quite different. Like for the trains is over 2020 is from Nanjing to Shanghai. But for the flights, the maximum number is 1449. So here we could see the distribution of TDI and TDME. Actually, for the time window, we use it like from 50 minutes and then to 4 hours. We found that the TDI shows the normal distribution, and